Hello everyone, welcome to the OneClass channel. My name is Andrew and I'm currently doing statistics and mathematics at University of Toronto. Today we'll be going over some commonly asked mathematics questions at both the high school level and college levels. And if you need some homework help or tutoring, check out the links in the description below. Okay, so now let's start our session. Okay, so the first question is asking us to, I'll write it down here, to take the derivative of tangent x, right? Yep. So before jumping to this question, I would first like to talk two things first. So the first thing is, we know that tangent x can be written as sine x over cosine x. Yeah. So that's the first thing I want to mention. And the second thing is that the rule of quotient. What's the quotient root in derivative? So it can be represented by d dx. If we have a function fx over gx, this will be equal to gx times the derivative of fx minus fx times the derivative of gx over gx squared. Yep. So by knowing these two things, let's go to our question. So like I just mentioned, instead of solving derivative of the derivative of sine x over cosine x, right? So it can be written like this. Sine x over cosine x. These two parts are equal, right? And notice that the right-hand side of the equation involves getting the derivative of quotient of the expression. Since there's a function over another function, which means sine x over cosine x, so now we need to apply the quotient rule. And yeah, recalling the quotient rule follows this. So d dx tangent x is actually equal to, you know what, just forget about that for a second. I'll just deal with the right hand side first. So the right hand side, d dx sine x cosine x. This is equal to cosine x d dx times sine x minus sine x d dx times cosine x over cosine x squared, right? So it is known that the derivative of sine x is cosine x. I'll write that down. We know the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. Hence, we simplify the above equation we have so this is going to be cosine x times cosine x minus sine x times negative sine x over cosine x squared. Right. So we're combining the numerator, so we got cosine x squared plus sine x squared over cosine x squared. Right. And this can also be written as cosine squared plus sine squared over cosine x. Recalling that we can substituting in the Pythagorean identity, which is given by 1 is equal to sine x squared plus cosine x squared. And the identity of secant, which is 1 over cosine x, is equal to secant x. By substituting this, we will get derivative dx sine x over cosine x is equal to 1 over cosine x squared, which means we just need to substitute this part by secant x, which is just equal to secant x squared. Right. Oops. So hence the derivative of the function tangent x is secant x. Secant x squared. Right. So let's recap what we covered in this question. So the first thing is we need to know that tangent is equal to sine x over cosine x. And then we need to apply the quotient rule, which is given by this part. And don't forget, for the denominator part, there's a exponent of 2. And also, remember the derivative of sine is cosine x, and the derivative of cosine x is negative sine x. And for the last part, we're calling the Pythagorean identity. So sine x squared plus cosine x squared is equal to 1. And the identity for secant, so secant x is equal to 1 over cosine x. Yep. So that's what we go for this question. Let's leave a comment there. Right. Good. Well done. All right. So our next question is asking us how to FOIL in math. Right. So FOIL method is one of the easiest way to remember how to multiply two binomials. And let's just separate FOIL. So F stands for first, O stands for outside, I stands for inside, L stands for last. And it is a sum of the product, uh, yeah, already, product. Yeah. So it's a sum of the product of the first terms and the product of the outer terms and the product of the inner terms and the product of the last terms. So let's use this example to explain. If we go x plus h times x plus h, so the first term is just going to be the very first term in each bracket, which will be the 2x. That's going to be our first term. And the outer terms is going to be the two terms that list to the edge of the bracket, which means where it is as a very left-hand side and a very right-hand side. So that's going to be our outer. And hx in opposite will be our inner. And the 2h is going to be our last term. Right. So let's use a example to explain how we're going to calculate this. Let's say we got a question like 2x plus 1 times 2x plus 1. Right. So in this case, we'll do our first term. So 2x times 2x, that's going to be 2x squared. And then the outer terms, which is 2x times 1, which gives us 2x. And then the inner terms, which is 1 times 2x, that's going to be 2x. And our last term, which is 1 times 1. Yeah. So this is from 2x times 2x. This is from 2x times 1. This is from 1 times 2x. And this is from 1 times 1. Right. So we can also rewrite these questions in this form. 2x squared plus 4x plus 1, which is also equal to 2x plus 1 squared. Right. So yeah, I think that's how we FOIL in math. Okay. Good job. Well done. Okay, so our next question. How could you use a rectangle to model the factors of x squared minus 7x plus 6? Right. So first we know the factors of x squared minus 7x plus 6 are x minus 1 and x minus 6. Therefore, we use these factors to represent the length and width of a rectangle, since the formula of calculating area of a rectangle is A is equal to length times width, which is the same thing as the identity of factor this. Right. So now we just draw a rectangle. So we see the area is equal to x squared minus 7x plus 6. Length is x minus 1, and width will be x minus 6. And since we're given, we know the formula of rectangle will be area is equal to length times width. So same thing, area, which is x squared minus 7x plus 6, is equal to length, which is x minus 1, times width, which is x minus 6. Right. And yeah, so the area of rectangle, which is a product of its length and width, will be equal to the polynomial. Right. And I think you can also draw it like this. Yeah, so either way works. And during the test, let's just write in a formal form. So A is equal to length times width, and our length will be x minus 1, width is x minus 6. And by applying the FOIL, and we got x squared minus 6x minus x minus 6 plus 6. Right. So we got x squared minus 7x plus 6, which is the binomial given in the question. Right. So that's the answer for this question. Oops. Okay. So coming up, we have what is root 200? So what is root 200? In other words, we just need to do the prime factorization of 200. And so let's first express 200 as product of its prime factors, which we can do it this way. So 200 is equal to 2 times 2 times 2 times 5 times 5. Because 2 times 2 is 4, 4 times 2 is 8, 8 times 5 is 40, 40 times 5 is 200. And therefore, we got root 200 is equal to 2 times 2 times 2 times 2 times 5 times 5. And we use a bracket to group the first two and the last two 5. because recalling that root 2 times 2, if we take a square root of that, that's going to be 2. And if we take a square root of 5 times 5, it's going to equal to 5. So you know that we can take a 2 out from there and a 5 out from there. So it becomes a 2 times 5 times, because there's only one 2 left. So that's going to be 10 root 2. Right. So that will be our final answer. And let's left a comment there. Correct. Okay, so our next question. Oops. So triangle QRS is a right triangle with the right angle, a vertex R, and the sum of Q and S must be okay. Okay, so we got 4 options. The first one is 45. The second one is greater than 45 but less than 90. C is 90, and D is greater than 90 but smaller than 180. All right. So first, let's begin by starting drawing the graph. So we know the rectangles QRS with the 90-degree angle at R. Yep. So that's what my triangle looks like. And whenever we come across a question like this, we always think about the sum of all interior angles of a triangle is equal to 180. I'll write that down here. The sum of all interior angles of a triangle is equal to 180 degrees, right? Hence, in other words, by using the three angles QRS, we can represent it by MQ plus S plus R is equal to 180. And we're given that angle R is equal to 90 degrees. It's given in the question. Right. So we just need to substitute in the value of r to the equation above. So our equation becomes to q plus s plus, instead of writing r, we're writing 90 degrees is equal to 180 degrees. And we minus 90 degrees on both sides, so we can get rid of the 90 degrees on the left hand side, which we only left with q plus f is equal to 180 minus 90, which means q plus s is equal to 90. Right. So the correct answer should be C. Yeah. Since the sum of q and s is equal to 90 degrees. And we can always substitute back to check to see if they are, like, after adding all this together, whether they're gonna equal to 180 or not. So 90, that's for R, and 90 for Q and S, and we go 90 plus 90 is 180, which means our answer is correct. I'll just write a conclusion there. Therefore, the sum of the two remaining angles must be equal to 90 degrees. Okay, so our correct answer will be C. Okay, and let's leave a comment there. Right. C equal to 90. Correct. Oh, correct. Will work. Right. Okay, so our next question is asking us how to measure the interior angles of a regular polygon. So first, let's talk about what irregular polygons are. So a regular, so the definition will be sides are all equal in length. That's the first condition. And the second condition is that angles are all equal. Right. So as long as they follow these two conditions, that's what we call a regular polygon. And so I'm gonna draw several graphs to help you understanding this. So let's start with the triangle. Right. So the interior angle of a triangle is 180, right? And now let's see, we got a hexagon. Should be something like this. Oops. Right. So it has 1, 2, 3, 4, 5, 6 edges. And so in this case, when we want to calculate the interior angle for hexagon, we can first divide it into 4 triangles. Right. So it should be look like this. So that's going to be triangle 1, triangle number 2, triangle number 3, and triangle number 4. And since we know each sum of the angle of triangle will be 180, and we got 4 of them, so we just use 4 times 180. It's equal to 720 degrees. So if we write a couple more about this, we will find the pattern, and I'll write the forms here. So engines, angle. So if we got a square, which means it have 4 engines, we will have an angle as 2 times 180, which is 360. And if we got a pentagon, which means I have 5 engines, the angle will be 3 times 180, which is equal to 540. And if we got a hexagon, which we just jotted about, hexagon, where we have 6 engines, that becomes to 4 times 180, which equals to 720. So we can find the pattern. So sum of interior angle will be n minus 2 times 180, where n is the number of engines, right? So you can see if we got 4 engines, we use 2 times 180. If we got 5 engines, we use 3 times 180. If we got 6 engines, we use 4 times 180. Yeah, and also things 5 times 2 is equal to 3. 4 times 2 is equal to 2. 6 times 2 is equal to 4. Right. So the sum of interior angle, I'll just write it again, should be n minus 2 times 180. Right. Oops. All correct. Okay. Coming up, we have our next question. How do you simplify? So for these questions, first thing I want to mention is that if we're given a root square of a fraction, and also if the numerator and denominators are greater, actually the numerator has to be greater or equal to 0, and the numerator has to be greater than 0, we can rewrite it as root a over root b. Right. So we can rewrite our questions like root 2 over root 3. Yeah. And to rationalize this, we will need to multiply root 3 to the numerator and denominator. Multiply root 3 to both the numerator and denominator. And note that root 3 over root 3 is equal to 1. Right. So we just rewrite what we got from the last step. We times a root 3 over root 3. Yeah. Because we want to rationalize the denominator. But if we only do it on the denominator part, that will change the value of the fraction. That will change the value of the fraction. So we need to do the same thing on numerator as well. Yep. So in this case, because 2 times 3 is equal to 6, and we got a 3 squared as a bottom. So root 6, because now we got square root of 9, which is just going to be 3. And I think that will be our final answer. Let's see. Yep. So our conclusion will be root 2 over 3 is equal to root over 3. Oh, correct. Moto. Right. So our next questions is asking what are conjugates. Right. So conjugate in mathematics, this word is used in 2 contexts. The first one would be when we're dealing with binomials which are partly rational, or dealing with binomials which are partly imaginary. I'll write it down here. Chart partly rational which are partly imaginary. Right. And also notice that the gate is where we change the signs in the middle of 2 terms. And I'll use another color. The conjugate is where we change the sign in the middle. Right. So some examples could be x squared plus 4 and x squared minus 4. Oh, that'll just be our expression and conjugate. Oops, that should be square. Okay, and b squared minus a, b squared plus a, root 2 plus 10, root 2 minus 10. Yeah. So these are some examples of the expressions and their corresponding conjugate. Right. And let's say we take the conjugate of x plus 2 and x minus 2, and we multiply them together. So we have x plus 2 times x minus 2. And by applying the FOIL method, we get x squared minus 2x plus 2x minus 4, which gives us x squared minus 4. And notice that two terms, negative 2x and positive 2x, are cancelled out each other during the process. So we only have x squared minus 4 left, which has another meaning, and which is the difference of 2 squared. And in fact, it's a factor form of a different of method. Of a difference of 2 squares is always a pair of conjugate. So in other words, we can rewrite this as a squared minus b squared is equal to a plus b times a minus b. Right. So we can always apply this when we rationalize the denominator, and especially when we encounter a square root from the bottom of a fraction. And let's try it with an example. So we got a fraction like this, x over 3 minus root 5. So we need to remove the square root as a bottom, as a denominator, and we need to multiply both numerator and denominator by its conjugate. And things we need to maintain the same value of the fraction. Right. So we have x over 3 minus root 5, and thinking about the conjugate of 3 minus root 5 will be 3 plus root 5. So we times 3 plus root 5 for both the numerator and denominator. Hence, our numerator will be just x times 3 minus root 5, and our denominator will be 3 minus root 5 times 3 plus root 5, which we can see it looks really similar to the formulas above. And so in this case, our a will be 3 and the b will be root 5. So we can apply this formula. Since a plus b times a minus b is equal to a squared minus b squared, so we have Actually, let's just switch the x to 2. Right. So our bottom, according to the distribution rule, we just got 2 times 3 plus 2 times 0.5. And for the bottom, we just got 3 squared minus 0.5 squared. So we got 2 times 3 plus 2 times 0.5. 3 squared is 6, is 9. And the square root of 0.5 is 5. So our denominator becomes to 4. And as you can see, we got a 2 for numerator, which means we can somehow get rid of 2. So in order to do this, we will write 4 as 2 times 2, since 2 can factor the numerator and denominator. So 2, we take a common 2 out, and a 3 plus 0.5 is what we have left in the bracket, 2 times 2. So here we can get rid of the 2. So our answer becomes to 3 plus 0.5 over 2. And yeah, I think that's the end of this answer. Yeah, just remember this formula is extremely useful. A squared minus b squared is equal to a plus b times a minus b. Right. So let's leave a comment there. Okay. It's asking the formula of 30, 60, 90 triangle. So there's one important thing we need to remember is that it is a one of two types special right triangle. As you can see, there's a 90 degrees there. And yeah, I wrote it down. One of the two types of special right triangle. And the other types will be the 45, 45, 90. Yep. And let's draw this triangle. So yep. So it is a right triangle, and I'll just call this part A, B, and C. So A is equal to 90 degrees, B is equal to 60, and C is equal to 30. 60, 30. So this type of special right triangle has measure of the hypotenuse that is 2 times that of the leg opposite the 30-degree angle, and the measurement of the other leg is the root 3 times of that of the leg opposite to the 30. So that means the BC will be 2 times of AB, which 1 times 2, that'll be 2. And AC will be the root 3 times of AB, which means 1 times root 3 is root 3. Yep. And yeah, don't mess the AC and BC up, because always remember the hypotenuse is the longest length in a triangle. And so the next thing will be the ratio. So the ratio of the base to longer leg to hypotenuse is 1, root 3, and 2. Yeah. Oh, and the other thing I need to mention is that it doesn't necessarily be like fixed 1, 2, and root 3. We can multiply each side by same number and it will maintain the property. So like I say, I want to times 2 for all of them, all of the side. So which means the hypotenuse will be 2 times 2, which means 4. And the AB will, instead of being 1, it will times 2 and becomes 2. And the AC will, the new AC will become 2 root 3. And I call that C star, B star, and A star. Yeah. Remember, as long as it follows the 1 root 3 to ratio, it always maintains the 30, 60, 90 degrees. Yeah, which means the angle, the degree for C star is still 30, and the degree of B star is still 60, and the degrees of A star is still 90. And yep. And also, when it comes to trigonometry, it will maintain the same property. So the sine C is equal to sine C star, and we say cosine A is also equal to cosine A star. Yeah. I think that's all we got for this question. And let's leave a comment there. Oops. Good job. Yeah, and I think that's all we got for today. Let me pause it. Yep, so I think that's all we got for today. And if you enjoyed today's Q&As and would like to be notified of when we do this next, please hit the subscribe button and notification bell below. And if you would like to submit your own questions, with these links in the description, remember to leave a like and a comment and share this video with a friend. And this has been Andrew from OneClass. I hope to see you soon. Bye.